Hey viewers, I am your host Muhammad Asif Jaja and you are watching YouTube channel ETV786. This channel is an education gateway and easy guide for business students. We are presenting course number 7 Business Statistics. This is part 4 of this course. Earlier to this lecture, we have presented 3 lectures on business statistics. Part 1 is definition, importance of statistics, data collection techniques and graphical representation. Part 2 is measure of central tendency and measures of dispersion. And part 3 is statistical data analysis and index numbers. This lecture includes number 1 time series analysis, number 2 probability and number 3 hypothesis testing. Time series analysis. Time series analysis is a statistical technique that deals with time series data or trend analysis. Time series data means that data is in a series of particular time period or intervals. Most commonly, a time series is a sequence taken at successive equally spaced point in time. Thus, it is a sequence of discrete time data. Examples of time series are heights of ocean tides, counts of sunspots, and the daily closing value of the Dow Jones Industrial Average. The types of time series data. The data is considered in 3 types. Number 1, time series data, a set of observations on the values that a variable takes at different times. Number 2, cross-sectional data, data of one or more variables collected at the same point in time. Number 3, pooled data, a combination of time series data and cross-sectional data. Objectives of time series analysis. Number 1, used to understand how time series works, what factors are affecting a certain variables at different points of time. Number 2, time series analysis provides the consequences and insights of features of the given data set that changes over time. Number 3, supposed to drive the predicting the future values of the time series variable. Number 4, assumptions. There is one and the only assumption, that is stationary, which means that the origin of time does not affect the properties of the process under the statistical factor. Take steps to analyze time series. Number 1, collecting the data and cleaning it. Number 2, preparing visualization with respect to time versus key feature. Number 3, observing the stationarity of the series. Number 4, developing charts to understand its nature. Number 5, model building, that can be AR, MA, ARMA and ARIMA. Number 6, extracting insights from prediction. Components of time series analysis. Number 1, trend, in which there is no fixed interval and any divergence within the given dataset is a continuous timeline. The trend would be negative or positive or null trend. Number 2, seasonality, in which regular or fixed interval shifts within the dataset in a continuous timeline would be bell curve or sawtooth. Number 3, cyclical, in which there is no fixed interval, uncertainty in movement and its pattern. Number 4, irregularity, unexpected situations, events, scenarios and spikes in a short time span. Limitations of time series analysis. Number 1, similar to other models, the missing values are not supported by TSA. Number 2, the data points must be linear in their relationship. Number 3, data transformations are mandatory, so a little expensive. Number 4, models mostly work on univariate data. Data types of time series analysis. There are 2 types of data. One is stationary and other is non-stationary. In stationary data, a data set should follow the below thumb rules without having trend, seasonality, cyclical and irregularity component of time series. Number 1, the mean value of them should be completely constant in the data during the analysis. Number 2, the variance should be constant with respect to the time frame. Number 3, the covariance measures the relationship between 2 variables. And non-stationary, this is just the opposite of stationary. Methods of time series analysis. Number 1, moving average. The commonly used time series method is moving average. This method is slick with random short-term variations relatively associated with the components of time series. The moving average, a rolling mean, in which MA has calculated by averaging data of the time series within K periods. Let's see the types of moving averages. Number 1, simple moving average or SMA. Number 2, cumulative moving average or CMA. And number 3, exponential moving average or EMA. Methods of time series analysis. Simple moving average or SMA. The SMA is the unweighted mean of the previous M or N points. The selection of sliding window data points depending on the amount of smoothing is preferred, since increasing the value of M or N improves the smoothing at the expense of accuracy. As shown in the Excel-based table and graph, the yearly average of air temperature in a city. Methods of time series analysis. cumulative moving average or CMA. The CMA is the unweighted mean of past values till the current time as shown in the table below. Methods of time series analysis, exponential moving average or EMA. EMA is mainly used to identify trends and to filter out noise. The weight of elements is decreased gradually over time. This means it gives weight to recent data points, not historical ones. Compared with SMA, the EMA is faster to change and more sensitive, where the noise is greater than smoothing factor and it has a value between 0 and 1. Represents the weighting applied to the very recent period. Let's will apply the exponential moving average with a smoothing factor of 0.1 and 0.3 in the given data set. This is the given data set. Methods of time series analysis, autocorrelation function or ACF. ACF is used to indicate and how similar a value is within a given time series and the previous value, or it measures the degree of the similarity between a given time series and the lagged version of that time series at different intervals that we observed. Python states models library calculates autocorrelation. This is used to identify a set of trends in the given data set and the influence of former observed values on the currently observed values. And then partial autocorrelation or PACF. PACF is similar to autocorrelation function and is a little challenging to understand. It always shows the correlation of the sequence with itself with some number of time units or sequence order in which only the direct effect has been shown and all other intermediary effects are removed from the given time series. Methods of time series analysis, observation. The previous temperature influences the current temperature, but the significance of the influence decreases and slightly increases from the above visualization along with the temperature with regular time intervals. Types of autocorrelation. There are 4 types of autocorrelations. Number 1, positive autocorrelation. Number 2, negative autocorrelation. Number 3, strong autocorrelation. And number 4, weak autocorrelation. Autoregression model. Number 1, this is a simple model that predicts future performance based on past performance, mainly used for forecasting when there is some correlation between values in given time series and the values that proceed and succeed back and forth. Number 2, an AR model is a linear regression model that uses lagged variable as input. States model library is used to provide autoregression model specific functions where you have to specify an appropriate lag value and train the model. It is provided in the AutoTag class to get the results using simple steps. Number 1, creating the model AutoReg, then call fit to train it on our dataset, then returns on AutoReg results object, and once fit, make a prediction by calling the predict function. Equation for autoregression model. The equation for the autoregression model. Let's compare y is equal to mx plus c. The following is the equation, wherein p is the past value, yt is equal to function of different past values, ert are the errors in time, and c is intercept. Implementation of autoregression model. Observation. Expected blue against predicted red. The forecast looks good on the 4th and the deviation on the 6th day. Implementation of moving average weights to simple moving average. In this graph, green line represents the simple moving average and yellow line exponential moving average where alpha is equal to 0.3. Recurrent neural networks. Recurrent neural networks is the most traditional and accepted architecture fitment for time series forecasting based problems. RNN is organized into successive layers and divided into number 1 input, number 2 hidden, and number 3 output. Each layer has equal weight and every neuron has to be assigned to fixed time steps. And remember that every one of them is fully connected with a hidden layer or input and output. With the same time steps and the hidden layers are forwarded and time dependent in direction. Components of recurrent neural network. Number 1, input. The function vector of x of t is the input at time step t. Number 2, hidden. The function vector h of t is the hidden state at time t. And this is a kind of memory of the established network, and this has been calculated based on the current input x of t and the previous time steps hidden state h of t minus 1. Number 3, output. The function vector y of t is the output at time step t. And number 4, weights. In the RNNs, the input vector connected to the hidden layer neurons at time t is by a weighted matrix of u. Please refer to the following picture. In this picture, internally weight matrix W is formed by the hidden layer neurons of time t minus 1 and t plus 1, followed by this the hidden layer with to the output vector y of t of time t by a V weight matrix. All the weight matrix U, W and V are constant for each time step. Advantages and disadvantages of recurrent neural network are R and N. Advantages. Number 1. It has the special feature that it would remember each information. So RNN is much useful for time series predictions. Number 2. Perfect for creating complex patterns from the input time series dataset. Number 3. Fast in prediction or forecasting. Number 4. Not affected by missing values, so the cleansing process can be limited. Now the disadvantages are: number 1. The big challenge is during the training period, and number 2. Expensive computation cost. Probability. Probability denotes the possibility of the outcome of any random event. The meaning of this term is to check the extent to which any event is likely to happen. For example, when we flip a coin in the air, the possibility is either head or tail will be the outcome. So the probability of a head to come as a result is 1 over 2. Formula for probability. The probability is the measure of the likelihood of an event to happen. It measures the certainty of the event. The formula for probability is given by P of E is equal to number of favorable outcomes divided by number of total outcomes. Thus, P of E is equal to N of E divided by N of S. Here, N of E is equal to number of events favorable to event E and N of S is equal to total number of outcomes. Terms used in probability. Random experiment. An experiment whose result cannot be predicted until it is noticed is called a random experiment. For example, when we throw a dice randomly, the result is uncertain to us. We can get any output between 1 to 6. Hence, this experiment is random. Terms used in probability. Sample space. A sample space is the set of all possible results or outcomes of a random experiment. Suppose if we have throw a dice randomly, then the sample space for this experiment will be all possible outcomes of throwing a dice, such as sample space is equal to 1, 2, 3, 4, 5 or 6. Term used in probability. Random variables. The variables which denote the possible outcomes of a random experiment are called random variables. They are of two types. Number 1, discrete random variables, and number 2, continuous random variables. Discrete random variables take only those distinct values which are countable, whereas continuous random variables could take an infinite number of possible values. Term used in probability. Independent event. When the probability of occurrence of one event has no impact on the probability of another event, then both the events are termed as independent of each other. For example, if you flip a coin and at the same time you throw a dice, the probability of getting a head is independent of the probability of getting a 6 in a dice. Term used in probability. Mean. Mean of a random variable is the average of the random values of the possible outcomes of a random experiment. In simple terms, it is the expectation of the possible outcomes of the random experiment repeated again and again or n number of times. It is also called the expectation of a random variable. Term used in probability. Expected value. Expected value is the mean of a random variable. It is the assumed value which is considered for a random experiment. It is also called expectation, mathematically expectation or first movement. For example, if we roll a dice having 6 faces, then the expected value will be the average value of all the possible outcomes, such as 3.5. Term used in probability. Variance. Basically, the variance tells us how the values of the random variable are spread around the mean value. It specifies the distribution of the sample space across the mean. Formulas of probability. Probability range is between 0 to 1, such as probability of A is greater than 0 and less than 1. Then rule of complementary events. Probability of A complement plus probability of A is equal to 1. Then rule of addition. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. Then mutual exclusive event. Probability of A union B is equal to probability of A plus probability of B. Then independent event. Probability of A intersect B is equal to probability of A into probability of B. Then disjoint events. Probability of A intersect B is equal to 0. Then conditional probability. Probability of A given B is equal to probability of A intersect B divided by probability of B. Then Bayes formula. Probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Solve examples of probability. Example 1. Find the mean and mode of the following data: 2, 3, 5, 6, 10, 6, 12, 6, 3, 4. Solution. The total count is 10. Sum of all the numbers is equal to 60. Mean is equal to sum of all the numbers divided by total number of items. So mean of this equation is equal to 6. Again, number 6 is occurring for 3 times. Therefore, mode is equal to 6. Solve examples of probability. Example 2. A bucket contains 5 blue, 4 green and 5 red balls. Adam is asked to pick 2 balls randomly from the bucket without placement, and then 1 more ball is to be picked. What is the probability he picked 2 green balls and 1 blue ball? Solution. Total number of balls is equal to 14. Probability of drawing 1 green ball is equal to 4 out of 14, and another green ball is 3 out of 13. 1 blue ball is equal to 5 out of 12. Probability of picking 2 green balls and 1 blue ball is equal to 4 out of 14 multiplied by 3 out of 13 multiplied by 5 out of 12. This is total to 60 out of 2184 or 5 out of 182. Solved example of probability. Example 3. What is the probability that Bush will choose a marble at random and that it is not black if the bowl contains 3 red, 2 black and 5 green marbles? Solution. The total number of marbles is equal to 10. Red and green marbles are equal to 8. Find the number of marbles that are not black and divide by the total number of marbles. So P that is not black is equal to number of red or green marbles divided by total number of marbles. That will be equal to 8 out of 10, or we can say that 4 out of 5. Solve example of probability. Example 4. Find the mean of the following data. Data is 55, 36, 95, 73, 60, 42, 25, 78, 75 and 62. Solution. First of all, we will sum the observations. That will be equal to 6, 0, 1. Number of observations are 10. Hence, the mean of this equation will be 6, 0, 1 divided by 1, 0 is equal to 60.1. Solved examples of probability. Example number 5. Find the median and mode of the following marks out of 10 obtained by 20 students. Marks are 4, 6, 5, 9, 3, 2, 7, 7, 6, 5, 4, 9, 10, 10, 3, 4, 7, 6, 9 and 9 respectively. Solution. First we will write the data in ascending order. Number of observation is equal to 20. So median of this equation will be 10th and 11th observation divided by 2. Which will be equal to 6 plus 6 divided by 2 are equal to 6. So median of this equation is equal to 6. Most frequent observation is 9. Hence the mode of this equation will be 9. Probability distribution. In statistics, the probability distribution gives the possibility of each outcome of random experiment or event. Suppose if we toss a coin, we cannot predict what outcome it will appear. Either it will come as head or as tail. The possible result of a random experiment is called an outcome, and the set of outcomes is called a sample point. With the help of these experiments or events, we can always create a probability pattern table in terms of variables and probabilities. Probability distribution of random variables. A random variable has a probability distribution which defines the probability of its unknown values. Random variables can be discrete or not constant or continuous or both. Through a probability density function that is representative of the random variable's probability distribution, or it can be a combination of both discrete and continuous. Two random variables with equal probability distribution can yet vary with respect to their relationship with other random variables or whether they are independent of these. The recognition of a random variable, which means the outcomes of randomly choosing values as per the variable probability distribution function, are called random variates. Types of probability distribution. There are two types of probability distribution which are used for different purposes and various types of the data generation process. Number 1, normal or cumulative probability distribution, and number 2, binomial or discrete probability distribution. Normal or cumulative probability distribution. The cumulative probability distribution is also known as a continuous probability distribution. In this distribution, the set of possible outcomes can take on values in a continuous range. For example, a set of real numbers is a continuous or normal distribution, as it gives all the possible outcomes of real numbers. Similarly, a set of complex numbers, a set of prime numbers, a set of whole numbers, etc. are examples of normal probability distribution. Also, in real life scenarios, the temperature of the day is an example of continuous probability. Based on these outcomes, we can create a distribution table. A probability density function describes it. Formula for normal probability distribution. The formula for the normal distribution is as follows, where mu is equal to mean value, sigma is equal to standard distribution of probability, If mean is equal to 0 and standard deviation is equal to 1, then this distribution is known to be the normal distribution. Here x is equal to normal random variable. Examples of normal probability distribution. Since the normal distribution statistics estimates many natural events so well, it has evolved into a standard of recommendation for many probability theories. Some of the examples are height of the population of the world, rolling a dice once or multiple times to judge the intelligent quotient level of children in this competitive world, tossing a coin, income distribution in countries' economy among poor and rich, the sizes of female shoes, weight of newly born babies range, average report of student based on their performance, etc. Binomial, a discrete probability distribution. A distribution is called a discrete probability distribution where the set of outcomes are discrete in nature. For example, if a dice is rolled, then all the possible outcomes are discrete and give a mass of outcomes. It is also known as the probability mass function. So the outcomes of binomial distribution consist of n repeated trials and the outcome may or may not occur. Formula for binomial distribution. The formula for binomial distribution is as follows, where n is equal to total number of events, r is equal to total number of successful events, p is equal to success on a single trial probability, and 1 minus p is equal to failure probability. Examples for binomial distribution. As we already know, binomial distribution gives the possibility of a different set of outcomes. In the real life, the concept is used for number 1, to find the number of used and unused materials while manufacturing a product. Number 2, to take a survey of positive and negative feedback from the people for anything. Number 3, to check if a particular channel is watched by how many viewers by calculating the survey of yes or no. Then number 4, the number of men and women working in a company. And number 5, to count the votes for a candidate in an election, and many more. Negative binomial distribution. In probability theory and statistics, if in a discrete probability distribution, the number of successes in a series of independent and identically disseminated Bernoulli trials before a particularized number of failures happens, then it is termed as the negative binomial distribution. Here the number of failure is denoted by r. For instance, if we throw a dice and determine the occurrence of 1 as a failure and all non-ones as successes, now if we throw a dice frequently until 1 appears the third time, that is r is equal to 3 failures, then the probability distribution of the number of non-ones that arrive would be the negative binomial distribution. Poisson binomial distribution. The Poisson probability distribution is a discrete probability distribution that represents the probability of a given number of events happening in a fixed time or space, if these cases occur with a known steady rate and individually of the time since the last event. It was titled after French mathematician Simon Denis Poisson. The Poisson distribution can also be practiced for the number of events happening in other particularized intervals such as distance, area, or volume. Poisson probability distribution examples. Number 1, a number of patients arriving at a clinic between 10 to 11 a.m. Number 2, the number of emails received by a manager between office hours. Number 3, the number of apples sold by a shopkeeper in the time period of 12 p.m. to 4 p.m. daily, etc. Probability distribution function. A function which is used to define the distribution of a probability is called a probability distribution function. Depending upon the types, we can define these functions. Also, these functions are used in terms of probability density functions for any given random variable. Normal probability distribution function. In the case of normal distribution, the function of a real valued random variable capital X is the function given by as follows, where P shows the probability that the random variable capital X occurs on less than or equal to the value of small x. Cumulative probability distribution function. For a closed interval a to b, the cumulative probability function can be defined as follows. Probability distribution function. If we express the cumulative probability function as integral of its probability density function fx, then the probability density function is as follows. Probability distribution function. In the case of a random variable where capital X is equal to b, we can define cumulative probability function as follows. Probability distribution function. In the case of binomial distribution, it is defined as the probability of mass or discrete random variable gives exactly some value. This distribution is also called probability mass distribution, and the function associated with it is called a probability mass function. Probability mass function is basically defined for scalar or multivariate random variables whose domain is variant or discrete. Suppose a random variable x and sample space S is defined as x is proportionate to S to A, and A is the member of R, where R is discrete random variable, then the probability mass function fx is proportionate to A, which is 0 and 1. For x can be defined as follows. Probability distribution table. The table could be created based on the random variable and possible outcomes. Say a random variable x is a real valued function whose domain is the sample space of a random experiment. The probability distribution P of x of a random variable x is the system of numbers where Pi is greater than 0, I is equal to 1 to n, and P1 plus P2 plus P3 to Pn is equal to 1. Prior probability. In Bayesian statistical conclusion, a prior probability distribution, also known as the prior of an unpredictable quantity, is the probability distribution expressing one's faith about this quantity before any proof is taken into the record. For instance, the prior probability distribution represents the relative proportions of voters who will vote for some politician in a forthcoming election. The hidden quantity may be a parameter of the design or a possible variable rather than a perceptible variable. Posterior probability. The posterior probability is the likelihood an event will occur after all data or background information has been brought into account. It is nearly associated with a prior probability where an event will occur before you take any new data or evidence into consideration. It is an adjustment of prior probability. We can calculate it by using the below formula. Posterior probability is equal to prior probability plus new evidence. It is commonly used in Bayesian hypothesis testing. For instance, old data proposed that around 60% of students who begin college will graduate within 4 years. This is the prior probability. Still, if we think the figure is much lower, so we start collecting new data. The data collected implies that the true figure is closer to 50%, which is the posterior probability. Solved examples of probability distribution. Example 1. A coin is tossed twice. X is the random variable of the number of heads obtained. What is the probability distribution of x? Solution. First, write the value of x is equal to 0, 1 and 2, as the possibility are there that no head comes, one head and one tail comes, and head comes in both the coins. Now the probability distribution could be written as the probability of x is equal to 0 will be calculated as 1/4, probability of x is equal to 1 will be calculated as 1/2, and probability of x is equal to 2 will be calculated as 1/4. We can put these values in tabular form. Solved example of probability distribution. Example 2. The weight of a pot of water chosen is a continuous random variable. The table gives the weight in kg of 100 containers recently filled by the water purifier. It records the observed values of continuous random variable and their corresponding frequencies. Find the probability or chances for each weight category. Solution. We first divide the number of containers in each weight category by 100 to give the possibilities, which are shown in the table below, according to their frequency range. Hypothesis testing. Hypothesis testing is a type of statistical analysis in which you put your assumptions about a population parameter to the test. It is used to estimate the relationship between two statistical variables. Let's discuss few examples of statistical hypotheses from real life. Number 1. A teacher assumes that 60% of his college's students come from lower middle class families. And number 2. A doctor believes that 3D diet, dose and discipline is 90% effective for diabetic patients. Null hypothesis and alternate hypothesis. The null hypothesis is the assumption that the event will not occur. A null hypothesis has no bearing on the study's outcome unless it is rejected. H0 is the symbol for it and it is pronounced as H0. The alternative hypothesis is the logical opposite of the null hypothesis. The acceptance of the alternative hypothesis follows the rejection of the null hypothesis. H1 is the symbol for it. Null hypothesis and alternate hypothesis. Example 1. A sanitizer manufacturer claims that the product kills 95% of germs on average. To put this company's claim to the test, create a null and alternate hypothesis. H0, a null hypothesis, average is equal to 95%. Alternative hypothesis H1, the average is less than 95%. Example 2. Another straightforward example to understand this concept is determining whether or not a coin is fair and balanced. The null hypothesis states that the probability of a show of heads is equal to the likelihood of a show of tails. In contrast, the alternate hypothesis states that the probability of a show of heads and tails would be very different. Simple and composite hypothesis. Depending on the population distribution, you can classify the statistical hypothesis into two types. Simple hypothesis, which is an exact value of the parameter, and composite hypothesis that specifies a range of values. For example, a company is claiming that their average sales for the quarter are 1000 units. This is an example of a simple hypothesis. Suppose the company claims that the sales are in the range of 900 to 1000 units, then this is a case of composite hypothesis. One-tailed and two-tailed hypothesis. The one-tailed test, also called a directional test, considers a critical region of data that would result in the null hypothesis being rejected if the test sample falls into it inevitably, meaning the acceptance of the alternate hypothesis. In a one-tailed test, the critical distribution area is one-sided, meaning the test sample is either greater or lesser than a specific value. In two tails, the test sample is checked to be greater or less than a range of values in a two-tailed test, implying that the critical distribution area is two-sided. If the sample falls within the range, the alternate hypothesis will be accepted and the null hypothesis will be rejected. One-tailed and two-tailed hypothesis example. Suppose H0 mean is equal to 50 and H1 mean not equal to 50. According to the H1, the mean can be greater than or less than 50. This is an example of two-tailed test. In a similar manner, if H0 mean is greater than 50 and H1 mean is less than 50, here the mean is less than 50, it is called a one-tailed test. Type 1 and Type 2 errors. A hypothesis test can result in two types of errors. A type 1 error occurs when sample results reject the null hypothesis despite being true. A type 2 error occurs when the null hypothesis is not rejected when it is false, unlike a type 1 error. Example. Suppose a teacher evaluates the examination paper to decide whether a student passes or fails. H0 then is student has passed and H1 student has failed. Type 1 error will be the teacher failing the student rejects H0. Although the student scored the passing marks, H0 was true. Type 2 error will be the case where the teacher passes the student. Do not reject H0. Although the student did not score the passing marks, H1 is true. Level of significance. The alpha value is a criterion for determining whether a test statistic is statistically significant. In a statistical test, alpha represents an acceptable probability of a type 1 error. Because alpha is a probability, it can be anywhere between 0 and 1. In practice, the most commonly used alpha values are 0.01, 0.05 and 0.1, which represents a 1%, 5% and 10% chance of a type 1 error respectively. For example, rejecting the null hypothesis when it is in fact correct. P-value. A p-value is a metric that expresses the likelihood that an observed difference could have occurred by chance. As the p-value decreases, the statistical significance of the observed difference increases. If the p-value is too low, you reject the null hypothesis. P-value example. Suppose you are trying to test whether the new advertising campaign has increased the product sales. The p-value is the likelihood that the null hypothesis, which states that there is no change in the sales due to the new advertising campaign, is true. If the p-value is 0.30, then there is a 30% chance that there is no increase or decrease in the product sale. If the p-value is 0.03, then there is a 3% probability that there is no increase or decrease in the sales value due to the new advertising campaign. As you can see, the lower the p-value, the chances of the alternate hypothesis being true increases, which means that the new advertising campaign causes an increase or decrease in sales. Steps in hypothesis testing. Step number 1. State your null and alternate hypothesis. Step number 2. Collect data. Step number 3. Perform a statistical test. Step number 4. Decide whether to reject or fail to reject your null hypothesis. And step number 5. Present your findings. Statistical quality control. The use of statistical methods in the monitoring and maintaining of the quality of products and services, one method referred to as acceptance sampling, can be used when a decision must be made to accept or reject a group of parts or items based on the quality found in a sample. A second method referred to as statistical process control uses graphical displays known as control charts to determine whether a process should be continued or should be adjusted to achieve the desired quality. Acceptance sampling. Assume that a consumer receives a shipment of parts called a lot from a producer. A sample of parts will be taken and the number of defective items counted. If the number of defective items is low, the entire lot will be accepted. If the number of defective items is high, the entire lot will be rejected. Correct decisions correspond to accepting a good quality lot or rejecting a poor quality lot. Producer risk versus consumer risk. Because sampling is being used, the probabilities of erroneous decisions therefore need to be considered. The error of rejecting a good quality lot creates a problem for the producer. The probability of this error is called the producer's risk. On the other hand, the error of accepting a poor quality lot creates a problem for the purchaser or consumer. The probability of this error is called the consumer's risk. Statistical process control. Statistical process control uses sampling and statistical methods to monitor the quality of an ongoing process such as a production operation. A graphical display referred to as a control chart provides a basis for deciding whether the variation in the output of a process is due to the common causes or randomly occurring variations are due to the out of the ordinary assignable causes. Whenever assignable causes are identified, a decision can be made to adjust the process in order to bring the output back to acceptable quality levels. Control charts. Control charts can be classified by the type of data they contain. For instance, an X chart is employed in situations where a sample mean is used to measure the quality of the output. Quantitative data such as length, weight, and temperatures can be monitored with an X chart. Process variability can be monitored using a range of R chart. In cases in which the quality of output is measured in terms of the number of defectives or the proportion of defectives in the sample, an NP chart or a P chart can be used. Control limits. All control charts are constructed in a similar fashion. For example, the center line of an X chart corresponds to the mean of the process when the process is in control and producing output of acceptable quality. The vertical axis of the control chart identifies the scale of measurement for the variable of interest. The upper horizontal line of the control chart, referred to as the upper control limit, and the lower horizontal line, referred to as the lower control limit, are chosen so that when the process is in control, there will be a high probability that the value of a sample mean will fall between the two control limits. Standard practice is to set the control limit at 3 standard deviations above and below the process mean. Quality standards. The process can be sampled periodically. As each sample is selected, the value of the sample mean is plotted on the control chart. If the value of a sample mean is within the control limits, the process can be continued under the assumption that the quality standards are being maintained. If the value of the sample mean is outside the control limits, an out of control conclusion point to the need for corrective action in order to return the process to acceptable quality levels. Teleometrics. Application of economic theory and statistical analysis to the study of history developed by Robert W. Fogel before 1926 and Douglas C. North before 1920, who were awarded the Nobel Prize for Economics in 1993 for their work. In Time on the Cross, 1974, Fogel used statistical analysis to examine the relationship between the politics of American slavery and its profitability. North studied the link between a market economy and legal and social institutions such as property rights in such work as Structure and Change in Economic History, 1981. Decision theory. Decision theory in statistics is a set of quantitative methods for reaching optimal decisions. A solvable decision problem must be capable of being tightly formulated in terms of initial conditions and choices or courses of action with their consequences. In general, such consequences are not known with certainty but are expressed as a set of probabilistic outcomes. Each outcome is assigned a utility value based on the preferences of the decision makers. An optimal decision following the logic of the theory is one that maximizes the expected utility. Thus, the ideal of decision theory is to make choices rational by reducing them to a kind of routine calculation. Total Quality Control, a TQC, system for optimizing production based on ideas developed by Japanese industry from the 1950s on. The system, which blends Western and Eastern ideas, began with the concept of quality circles, in which groups of 10 to 20 workers were given responsibility for the quality of the products they produced. It gradually evolved into various techniques involving both workers and managers to maximize productivity and quality, including close monitoring of staff and excellent customer service. The concept of Kaizen, the notion that improvement must involve all members of a company, is central to TQC. YouTube channel ETV786 is an easy guide for business students. What you need is our preference. So stay connected and prepare us through your comments to set our next targets. Please view, like, share and comment the videos and subscribe the channel. Bye bye till the next show.